Today's lesson, you guys, is honestly a lot of review. We're talking about Pythagorean theorem and its converse. So we're familiar with Pythagorean theorem. We've been using it a lot in the past couple weeks, actually. So this should not be a surprise to anybody, this first part. The Pythagorean theorem says if a triangle is right, then we all know the formula, a squared plus b squared equals c squared. Okay, so this only works in right triangles. Remember that. So if you got a right triangle, the biggest thing to note is that C is the hypotenuse across from the right angle. The other two sides are A and B. And it doesn't matter which one's which. So again, you guys know that. You know that if something's a right triangle, then you can use Pythagorean theorem to find a missing side. So on this first example, and the right angle should be in there. So let's go ahead and put that in. It says find each missing side and leave your answer in simplest radical form. Okay, so that's big to know. We've been doing a lot with radicals. So across from the right angle is the hypotenuse, which is 20. I need to put that alone. So I'm going to set this up, x squared plus 8 squared equals 20 squared. All right, so 8 squared, we know that one. Do your exponents first. 20 squared is going to give you 400. Subtract over the 64. And then I just need to square root both sides. So here's where your factor trees are going to come in. So I'm going to go off to the side here and simplify my radical. So, all right, I'm not totally sure what goes into this, but I know it's even, so we'll cut it in half. 2 and 168. I know 168 is even, so I'll do 2 and 84. Let's try 4. Yeah, 4 and 21. And then 2 and 2, and 7 and 3. A lot going on here. Okay, so let's rewrite this. Let's see, I see a pair of 2's, and I see another pair of 2's. So 2 2's come out, making it 4. 7 times 3 stays under. 4 radical 21. Okay, so we've done a lot with that. Like I said, that's not new to us. This is not really about Pythagorean theorem, you guys. This is about the converse of Pythagorean theorem, because you've done Pythagorean theorem for years now in your math classes, but you've probably never looked at the converse. Okay, so if you remember from first semester geometry, the converse of a conditional statement, like if this, then that, the converse is just when you flip the statement around. So we're going to write it backwards pretty much and say if a squared plus b squared equals c squared, if that holds true, then you know that a triangle is right. And it makes sense. I mean, obviously, if the Pythagorean theorem works, it's a right triangle because it only works for right triangles. So you're going to see stuff like this next example of using the converse. They give you a triangle. Do not go off of looks. On this first example, FYI, that right angle would have been there on like an example homework problem. So this one doesn't have it. It looks like a right angle, but I can't assume. If they're asking me if this is a right triangle, I'm going to test the Pythagorean theorem. Now, the biggest side has to be the C value. So that's 85. So 84 and 13 would be A and B. So I'm going to say, okay, A squared plus B squared, I don't know, does that equal C squared? So put a little equal sign underneath. I don't know, are these two the same? I got to check. So these are massive numbers. 84 squared plus 13 squared is 7225, and 85 squared, what do you know? 7225. Okay, so since these do equal each other, I know that this triangle is a right triangle. Pythagorean theorem works, I'm good. Now, if you have 3 numbers that make a right triangle, like this example, those 3 numbers are called a Pythagorean triple. Okay, so a Pythagorean triple is just 3 numbers that make the Pythagorean theorem, a squared plus b squared equals c squared, true. So I would call 84, 13, and 85 a Pythagorean triple. All right, so kind of common sense if you know what's going on with the Pythagorean theorem. The converse is not terribly different. This last theorem on the back, though, this is where you'll probably see something you've never seen before. So, all right, well, what if this last example, these would not have equaled each other? Well, that would have told me this was not a right triangle. And if it's not a right triangle, it has to be either acute or obtuse. So that's what this next theorem talks about. Okay, so here's what it says. There's two parts. If c squared is bigger than a squared plus b squared, so they're not equal, it's not right. If c squared is bigger, I always think, okay, bigger is obtuse. Acute's kind of like a smaller angle. So if c squared is bigger than a squared plus b squared, it's an obtuse triangle. And then if you flip the sign around, if c squared is less than or smaller than all this other stuff, so think like it's less than, it's smaller, that's an acute triangle. Okay, so they'll give you examples like these last three here, and they'll say, hey, these are the lengths of the sides of a triangle. Classify or name each triangle as either acute, right, or obtuse. You are going to test the Pythagorean theorem, okay? And I write c squared first on these examples because I have a better time remembering, like, if c squared's bigger, it's obtuse. If c squared's smaller, it's acute. So I write c squared first. Please be careful. It doesn't automatically go A, B, C. C has to be the biggest side. So on example A, 14 is my C value. So I'm going to do 14 squared and then put a question mark because I don't know if it's equal to, greater than, less than, whatever. And I'll put A squared plus B squared on the other side. Okay, so now it's just a matter of putting it in your calculator. I got 196 for the C squared. And 157 on the right side. Okay, so obviously 196 is greater than 157. So since c squared is bigger, this is an obtuse triangle. All right, the next one, again, be careful. 9 would be the c value. The biggest one has to be c. So I'm going to say 9 squared. How does that compare to 7 squared plus 8 squared? Okay, so 81, and I've got 7 squared plus 8 squared. Whoa. I'm a mess here. There we go. 113. Okay, so this time 81 is smaller than 113. So if c squared is less, it's an acute triangle. All right, last one. Be careful, 82 is the c value. So 82 squared, how does that compare to 18 squared plus 80 squared? So 6,724 and 6,724. Okay, if they equal each other, Pythagorean theorem works, so it's got to be a right triangle.